Hello everyone. So in this video, we are going to discuss an important question that related to induction machine. Uh, you might have seen in case of induction machine, when an induction machine is operating in motoring mode, the operating sleep lies in the very low range. Maybe the sleep lies the in between somewhat 0.01 to sometimes 0.09 per unit. So in this range, basically, induction machine sleep lies. It can go beyond 0.09, but it is expected your induction machine is operating in motoring mode. The sleep will be somewhat in the lower range. But why it is so? The question is why it is so. So first of all, to understand this concept, you have to know the concept of uh, relative motion in between the rotor conductor and rotating magnetic field. So sleep simply means the ns minus nr with respect to ns, right? More sleep means the relative motion in between rotor conductor and rotating magnetic field is more, and less sleep means the relative motion in between the rotor conductor and rotating magnetic field is also less. Now, tell me one thing: when sleep is less, definitely the relative motion in between rotor conductor and stator rotating magnetic field is less. That means the induced voltage in the rotor circuit will be less. If sleep is less, the induced voltage in the rotor conductor will also be less. Like AC2 will also be less. If it is less, that means the rotor current will also be less. If rotor current is less, that simply means the rotor copper loss will be less, right? And not only that, the rotor current is less. That means the rotor copper loss is less, and machine's efficiency will increase because losses decrease. That means the efficiency will increase, right? So that means like it's a very good advantage. Yes, if you operate your induction motor in the low slip region. And one more thing, like if the rotor current is less, the reflection will come to the stator side. That current will also be less, right? Because my stator current is simply nothing but IR prime plus I phi, the magnetizing current. So this quantity will also be less. If this quantity is less, that means the stator copper loss is also less. So it is a great advantage for us, right? It was the first point that it increased the efficiency, and also uh, the converse, you can say the rotor copper loss decreases and the stator copper loss decreases. Okay, if the losses decreases, that means the heat generates in the machine gets also reduced. That will that is actually good for induction machine life. So it also increases the lifespan of induction machine. Now come to the second point. If you recall the induction machine equivalent circuit, or the variable, that the mechanical load that actually represented by a variable resistance quantity R2 prime 1 minus S by S, right? You can simplify like this: R2S, R2 bar 1 by S, like this way. So if your sleep is, let's say your sleep is less, that means this entire quantity will be high. So your mechanical output power will be very high at that time. Now it is now it is crystal clear. Like if you operate an induction machine at low slip region, you can your mechanical power output will be very high. So it is great advantages for us, right? So these are the two main reasons we are operating our induction machine at very low slip region. Okay, and there is a few other points are there. Like if you see the torque slip characteristics or torque speed characteristics of induction machine, this is electromagnetic torque generated by induction machine. This particular area is called the stable operating region. Okay, and this is the low slip region. Here mainly your induction machine will operate in the motoring mode. I'll discuss about why this area is called stable operating region. Maybe if you want, I can surely discuss about that. But I hope it is clear why induction machine slip is towards the lower side when it is operating in motoring mode. Okay. Yeah. Thanks for listening.